Hello everyone, welcome back to my channel. Today I am going to continue with class 11 or first PUC chapter 2, encoding schemes and number system. I have already uploaded part 1 and part 2 of this chapter in previous videos. If you haven't watched them yet, I will share the links in the description box. Please check them out. And also I am excited to announce that my book is now available on Amazon, on Flipkart. It is all in one guide, textbook, question bank, and lab manual combined. I have included answers in very simple English so everyone can easily understand. And also, if you haven't subscribed my channel, please do the subscription so that you can stay updated with my upcoming classes. Our topic for today is binary to octal conversion. To make this process easier, we will be using here the 4 to 1 table. So this table will be a quick reference. It will allow you to directly convert the binary numbers to octal number or octal number to binary number. So what does it meaning of 4 to 1 is nothing but whatever the octal numbers are here. Octal numbers are what? From 0 to 7. We are going to write the 3-bit of the code. That is nothing but the binary equivalent. Now, how come you form? Why I have to take only 4 to 1? I'll tell you the reason. What is the binary base? The binary base is 2. So, what is the 2 to the power of 0? 2 to the power of 0 is nothing but 1. That is what I have mentioned here. And what is the 2 to the power of 1 is nothing but 2. And 2 to the power of 2 is nothing but what? 4. But when I am taking 2 to the power of 3, what it will happen? It will go to 8. But 8 is not the octal number, right? Because the octal number will start with 0 to 7. So we are going to create now the weightage. How can we give the weightage? I'll tell you. First you have to take the value what is 0. And what is the weightage of 4 to 1? Nothing. So you have to mention. So 0, 0 and 0. So the octal number of 0 is the binary equivalent is 0, 0, 0. And what about 1? So 1 there is a column here. So we are going to weightage for this column. So 0, 0 and 1. And what about 2? 2 column you are giving the weightage. So 0, 1 and 0. Weightage is nothing but I am adding 1 to that, right? And what is the 3? 3 is not, no columns are there, but there is an option 2 plus 3. If you add these two columns, you will get the answer 3, right? So you are giving the weightage here 1 and 1. Clear? Now 4. 4 directly the columns are there. So you have to give what? 1, 0, 0. And what about 5? 5 you have to add. 4 plus 1 is 5. So I am giving weightage to 4 and 1 and remaining will be 0. What about 6? 4 plus 2 is 6. So here 1, 1 and remaining what? 0. What about 7? 4 plus 2 is 6, 6 plus 1 is 7. So all it will be 111. This is what you have to prepare what? The 3-bit, the binary code. Now directly by using this table, we are going to convert binary to octal and octal to binary. For example, I want to convert here now for octal number as 3, 4 and 7 to the base 8. What is the equivalent of binary? How can you convert it? You can see what is the 3. So 3 is nothing but 0, 1, 1. So 0, 1, 1. And what is 4? 4 is 1, 0, 0. So 1, 0, 0. And 7 is what? 111. That's all. That is the answer for binary. Clear? And the same way, if I am giving the value here 1, 1, 0, 1, 0, 1, 0, 1, and this is my binary. And how can you convert to octal now? So you have to, what you have to do, I will tell you. From the last digit, you are going to take 3 bits because we are preparing everything 3 bits, right? So 3 bits you are going to take it. So this is 1 bit and this one another one. Here only 2 we are having. So what we are going to do now? We are going to add one more 0 here. So 0 I am adding extra here. So to make it 3. If you have only 1, then you have to add how many zeros? 2 zeros you have to add it. Clear? Now from the last we are going to add it. Now what you are going to do now? 101. What is 101? Is nothing but 5. And here what? 010. 010 is nothing but 2. And what is this? 011. So 011 is nothing but what? It is a 3. So what is the answer of this? It is nothing but 3 to 5 to the base 8 is the answer. Clear now? This is very simple. If you remember this 4 to 1 table, easily you can convert binary to octal and octal to binary. And what about the binary to hexadecimal? Again, in hexadecimal, we are going to add 8 here. As I told you, right? 2 to the power of 0, then 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. But when you take 2 to the power of 4, it is reaching for 16. So, 16 is not a value for the hexadecimal. Now, the same concept we are going to prepare what? 8421. And here, hexadecimal, we will be having the number from 0 to 15. But from 10 to 15, you are going to mention what? Capital letter A to capital letter E. Now let's prepare this now. Now I'm taking 0. So 0, nothing is there. So what is the answer? 0, 0, 0 and 0. And what about 1? So here you have to add 0, 0, 0 and 1. What about 2? 2 column you have to give the weightage. 0, 0, 1 and 0. What about 3? 2 plus 1 is 3. So 2, 0, 0, 1 and 1. And again 4. 4 column you have to give 1. And remaining 0, 0 and 0. What about 5? 4 plus 1 is 5. So 1 and 1. So remaining column you have to make it as 0. 6 means 4 plus 2. So 4 and 2 you are giving 1. Remaining it will be what? 0. And 7 means what? 4, 5, 6, 7. So this 3 column you are going to give 1. And remaining column will be 0. Next 8 is what? 8 directly it is there. Then 1. Then remaining it will be 0. Then 9 is 8 plus 1 is 9. So 8 and 1 9. So 0 and 0. What about 10? 8 plus 2 is 10. So 1 and 1 I am giving. Remaining it will be 0. And 12 is 8 and 4. So 1 and 1. Remaining what? 0 0. Then 30. 13 is what? 8 plus 4 is 12. 12 plus 1 is 13. So 1, 1 and here 1, then 0. What about 14? So 8 plus 4 is what? 12. Then 13, 14. So here 1, 1, 1, then 0. Then what about 15? All are 1. Clear? Is this way you have to create what? The table. After that, now the direct conversion we are going to do. Now if I am taking the binary to hexadecimal 1 0 1 0 1 0 1 0, it is what? 4 bit, right? The same concept only we are going to do it. So what is that? 4 value you have to take it instead of 3 bit for octal, 4 bit for hexadecimal. So 1 2 3 4, and again here 1 2 3 4. In case if I am adding one more here 1, so what you have to add? You have to add now 2 4, no, 1 2 3 0, you have to add it. Clear now? So the same concept we are going to use it. Now see here 1 0 1 0. What is 1 0 1 0? You have to check it out. Where it is? 1 0 1 0 is nothing but 10. So instead of 10, what you will be mentioning? A you will be mentioning. And here 0 1, sorry, 1 0 1 0. Again the same. What you have to mention here? A you have to mention it here. After that 0 0 0 1. So 0 0 0 1 is nothing but 1. So what is the answer here? 1a to the base 16 is the answer. Now the same way if I am giving here 2 4 a and b. What is the answer? Hexadecimal to binary. So what is the answer? Directly you can apply it. What is the 2 value? 2 is nothing but 0 0 1 0. And what is the 4? 4 is 0 1 triple 0. So 0 1 double 0. Sorry, double 0. Then what is A? A is nothing but 1 0 1 0. And what is B here? B is nothing but 1 1 0 0 1 0 0. And to the base what? 2. I hope everyone is clear. So octal means 3 bit, hexadecimal means 4 bit. Now, if they're asking octal to hexadecimal, how can you do the conversion? First, what you have to do, step 1, convert octal to binary you have to do. Octal to binary, what you have to do? You have to prepare what? 4 to 1 table, right? Directly you can prepare the table and convert it. After that, binary to hexadecimal, you are going to do what? 8 4 to 1 table. Then you have to find out what? Octal to hexadecimal. Next is what? Hexadecimal to octal. The same. Convert hexadecimal to binary, then binary to octal. Clear now? So this is what you will be converting octal to hexadecimal and hexadecimal to octal. Okay, now this type of question, definitely they will be asking for the 5-mark question. It is very important question. So how can they ask, it seems like very important question. How they will be asking, say for example, they will be asking CAD is a hexadecimal. You have to convert to binary, convert to decimal, convert to octal. So from here, hexadecimal to first you have to convert to binary. After that, hexadecimal to decimal. After that, hexadecimal to octal. Now let's see. So CAD is a hexadecimal. How can you convert to the binary? Very easy, right? You are having what? The table, 8421 table. Just now we have discussed, right? 8421 table. So C means what? 1101. A means 1010. And D means 1110. The same you have to write it here. So how can you write it? 1101, then 1010, then 1110. This is the answer, am I right? So by using the table, you can convert it this. After that, CAD. So CAD to the base 16. How can you convert to binary? Sorry, decimal. Decimal, how can you convert? You have to multiply by 16 to the power of positional value. So what is C here? C is nothing but 13. And what is A? A is nothing but 10. What is D is nothing but 14. So you have to take here 14 into 16 to the power of 0. Remember? And 10 into 16 to the power of 1. And again, here 13 into 16 to the power of 2. Now you have to write the answer. So anything to the power of 0 is what? 1. So 14 into 1 is 14. Again 10 into 16 is what? 160. And next one is here 16 square is 256 into 13 is what? 300,328. Now finally you have to add everything. So what will be the answer you will be getting? 3502 is the answer to the base what? Decimal. After that what you have to do? Hexadecimal to octal. So just now we had discussed, right? Hexadecimal to octal, there will be a 2 step. First convert hexadecimal to binary, then binary to octal. So hexadecimal to binary already we converted, right? We have taken that same thing. So CAD to the base 16, we are going to convert what? 8. So first step what? You have to step 1. You have to convert hexadecimal to binary, right? I'm not writing fully, just writing like this. After that, what is the answer you got? The same answer you have to write it, right? So 1101, then 1010, then 1110. This is the answer you got it, right? Then what you have to do? Now you have to convert. The step 2 is convert what? Binary to octal. Octal, how can you do it? Octal means 3-bit. So from the last, you have to convert to 3-bit. Here. So we no need to add anything 0. So 110 is what? You can go to this one and you can see 110 is 6. The same by using the table, you can convert it. So 6, and here also 6. Here also 101 is nothing but 5. Here 110 again it is 6. So the answer we got it octal. This is what you have to solve it. Okay, and next one, the mind map, as I told you, it's very easy for you to remember. So the first mind map is how can you convert decimal to other number system. Other number system what? Binary, octal and hexadecimal. That you have to remind. It is called a reminder method. Reminder method means what? Divide the number by, if it is a binary, divide the number by 2 and collect the remainder. After that you have to write what? Sum from bottom to top. And again the octal number, divide the number by 8 and collect the remainder. And bottom to top, you have to write the answer. Hexadecimal also, divide the number by 16 and collect the remainder. This is what you have to do for the decimal to other number system. If they are asking in point, what you have to do? You have to multiply by the number. Next one, mind map. For the other number system to decimal. right? Other number system can be binary, octal, or hexadecimal. So what is the formula you have to remember? Number into base to the power of positional values. Binary means number into 2 to the power of positional values. Octal means number into 8 to the power of positional values. Hexadecimal is number into 16 to the power of positional values. So anything to the power of 0 here you have to remember is what? 1. After that you have to add all the number, you will get the answer. Next one we had discussed now. How can you convert the binary to octal and octal to binary is 4 to 1 table. Again, binary to hexadecimal and hexadecimal to binary is 8 4 to 1 table. Then octal to decimal is step 1 and step 2, convert to octal, then binary to hexadecimal. Next, hexadecimal to octal is convert hexadecimal to binary, then binary to octal. So these are the mind map you have to remember. Better you can write it in your notebook in one page so that you will not forget the thing. Okay. Wish you all the best for your exam. And next class I'm going to start the new chapter. Until then, bye. Please, those who didn't subscribe my channel, please do the subscription. If this video is helpful, please share it with your friends. Thank you.